Start recording. The very last one we added ammonium hydroxide. What's the issue with ammonium hydroxide? I noticed a lot of people struggling with this one. So the ammonia part is going to hold true. That's not going to change. But our last equation, how the hydroxide interacts, is going to be problematic. And a lot of people got stumped on this. Okay? Draw it out whatever happens, regardless of what you think you may be drawing. Write it out. Hydroxide should act as what? Base. Why should it act as a base? Kind of accept that. Electrons. It's negatively charged, which means it should act as a base. What's our definition of a base? Accepts hydrogen ions. So OH minus needs another hydrogen ion. So what do we generate? H2O. Where did it get that hydrogen ion from? Water, which was H2O. If we take a hydrogen ion away from H2O, what do we get? OH minus. Okay. What's interesting about adding hydroxide ion to water? Gives you hydroxide ion and water. Nothing really special happens. Hydroxide immediately goes into the solution and gives us that pH shift right away. Okay? So we could almost ignore that equation. Okay? We're always going to be increasing the pH when we add hydroxide. Why increasing? Because hydroxide is a base. Deciding now whether this solution is acidic or basic. That's the tricky question. What did the ammonium ion do? Made it acidic. What did the hydroxide ion do? Made it basic. Which one wins? Is this neutral, acidic, or basic? Comes back to the strength of those species. Okay? When I add hydroxide, I get exactly one hydroxide molecule, or one hydroxide mole. When we go through and add a mole of ammonium ion, does it completely dissociate to generate 1 mole of H3O+? No. How do you know it doesn't completely dissociate? It's not strong. Which means the concentration of H3O+ from the ammonium ion is less than the concentration of hydroxide. Which means the solution is basic. So to evaluate that last one, deciding whether it's acidic or basic, what we really need to know is what that equilibrium constant is. Okay? This one was an easier one, if you will, because we compared a weak to a strong. The strong is dominating. What if we had 2 weaks? How would we decide if it was acidic or basic? We'd have to go through and evaluate how much H plus is generated, how much OH minus is generated, and compare the two. Whichever one was in a higher concentration is the one that determines the acidity or basicity of that solution. That would be an exceptionally difficult problem. Okay? Questions about that? Okay. So what happens when we flip it over? Because you said you didn't have any questions about it. Okay, if you flip that quiz over, now instead of having to deal with all these conceptual problems where you just draw stuff, you just get to use a calculator. Lucky you. Okay. So, where did I put all the quizzes? So let's go through and try and set a few of these up. I'll let you take it home and work on them and kind of verify how far you can get. Okay. I do expect them turned in tomorrow morning. Yes.
For number 6, room at all?
What's that?
For number 6, because I think you have to do 2 of these. So,
kind of. You actually don't need to do 2 of those. It's the exact problem. So when we go through and take a look at the problems on the back, number 3 is more of a straightforward answer. Number 4, 5, 6 are all connected to each other. Okay? If you go through and do the work for 4 and 5, you will be able to get the answer for 6. Okay? Without having to do a whole bunch of extra work, which is why 6 doesn't have any space, even though it looks like it's a beast of a problem. Okay? So let's go through and try and set up question 3 first. So, first step. What do I recommend you do? Okay, we could write out the equation. I can accept that. So we've got a solution of lithium 2 carbonate. And we're going to add that to water. It's going to go towards products. Is it a strong acid or base? Is it strong anyway? No. Which means the arrow I should show should be equilibrium. Am I particularly concerned about the lithium ion? No. Why not? It's a spectator ion, so we could go through and just draw out carbonate plus water goes to our products. So we can ignore the lithium altogether, okay, according to our solubility rules. What's the product of this reaction? Carbonate should act as a base. How do you know it acts as a base? It has electrons. So have it act as a base. What should it do? It needs to pull a hydrogen off. So we would draw HCO3 minus and OH minus. Why did I not draw H2CO3? Kind of a trickier question. This species is known as, if we went all the way to its acid, as diprotic. Okay? In this case, we could look at it as dibasic. It has 2 negative charges. It can pick up 2 hydrogens. Should we draw it out picking up 2 hydrogens? No. Why not? Problem said don't do that. That's the first and easiest method. Why did the problem tell you to only do 1? Because if we tried to mathematically do it with with 2, we would end up finding out that our math doesn't add up. Okay? The ability of that species to pick up a hydrogen or act as a base changes as it picks up more hydrogens, which means the equilibrium constant changes, which means everything else changes. So we can only look at one step at a time. This goes back to, again, one of the things we talked about when we're looking at our acid-base chemistry. What makes it nice? We only have to look at 1 or coefficients of 1 through our balanced equations. Okay? Because we can only evaluate 1 step at an individual time. So it's a good thing. Makes our equations a little bit easier to work with. What's the next thing we could go through and do?
Convert the Ka to Kb.
I don't even want to quite get into that yet.
Draw ice chart.
I would draw out your pH equals 0.15 molar. Pull it out of the problem. Okay, what else do you know? 4.8 times 10 to the minus 11. Wants to know the pH of the solution. Am I reading the wrong question? No, I'm reading the right one, aren't I? Yeah. Oh, no. It wants to know the pH, sorry. I don't know why I didn't notice the units there. It wants to know what the pH is, and it says that our concentration of our carbonate ion is 0.15 molar. Okay. To get the pH, what do we need to know? Concentration of H+. Okay? So we could go through and look at our balanced equation. Anybody see H+ show up? No. Okay, so that's a bit tricky. We would have to determine the concentration of OH-. Once we knew the concentration of OH-, we could then convert that into H+. So already we're going, okay, this is going to involve a lot of steps. Next issue. We could start to plug some information into this. generate an ice chart. So we got initial, change, equilibrium. What's our initial? Do we have any of this information? We know our carbonate concentration is 0.15 molar to start. Do we know the concentration of water? Doesn't matter. Why not? It's a liquid. It's in there in vast concentrations. The concentration is not going to change. What's our initial concentration of HCO3 minus and OH minus? We could calculate Q. What would we get for Q? 0. By definition, Q would be less than K, which means shifts towards the right, which means plus, and minus. How much does it shift? Some X amount. Let's say our carbonate is X. What does that mean OH minus is? What does that mean our CO3 minus 2 is? What's our equilibrium concentration for everything? What's our equilibrium expression for this equation? K equals CO3 minus OH, minus over CO3 minus 2. All right, we could go through and put in some values into here. We've got x squared over, I already forgot my numbers, 0.15 minus x. How would we solve for x? Gave us something. Good answer. What something did it give us? K. What K did it give us? Ka. What K expression are we now looking at? What K expression are we looking at? This is the KB. If we now go in and plug in Ka, what would we get for x? The wrong answer. Okay? This is one of the reasons why I recommend you write it all out. Okay? And then you have to check. Is the K constant you're given the same for what you are now solving for? In this case, it's not, so what do we have to do? Convert Ka into Kb. How do we do that? Since I'm seeing that questionable look back there. We know the Ka times the Kb equals
1.0 times 10 to the negative 14.
Our Kw, Kb equals 10 to the minus 14 over our 4.18 times 10 to the minus 11. We now have the Kb. We can now plug it into our equilibrium expression. And we could solve for x. In the process of solving for x, I think that's an 11. Okay. What do we get for a Kb? What would you like to do now? Quadratic? You could, by all means, go ahead and punch in the quadratic. I would go through and make the assumption first. I would assume x is substantially smaller than 0.15, which means my assumption equation becomes x squared over 0.15 equals 2.08 times 10 to the minus 4. 2.08 times 0.15 times 10 to the minus 4 square root gives me my x. That x number would be, I didn't actually solve for it. Anybody have that x number? To test, we would take that number and divide real quickly in the calculator by 0.15. Multiply by 100 and you get 3%. We get a number less than 5, which means the assumption is valid. We're good to go. Almost guaranteed on a multiple choice test. What number do you think shows up? 0.00548. Good job. You solved for x. Did you answer the question? No. What was x? Concentration of OH minus. What do we need to do? We could take it to the POH. That's probably what I would do. How do we take it to the POH? The negative log, sorry, the 10 to the negative is when you're going the other direction, of our concentration. What do we get for our POH?
2.26.
What number shows up on the multiple choice answers? 2.26. Did you get it right? No, why not? You still didn't answer the question. The question asked for the pH. What do you have to do now? 14 minus our POH gives us the pH. Okay? Make sure when you answer your questions, you know what the question asked for. And that when you solve, you know that that is exactly what you're answering. Okay? Particularly on a test that's difficult to get through. What are the odds, or where do you expect to see this question? And then we'll end this. Show your work. Okay? What would I recommend you do with show your work here? I would show all the work up to entering it into a calculator, and then I would leave it alone. Okay? Show your work, it's 3/4 of the point is for your work, or your credit. Okay? If you show all the work except the calculator part, you just got 3/4 of the points. Okay? So what if you missed the multiple choice? Okay? Not that big of a deal. That gives you 75% on the exam. That's a substantial jump from the 62% average. Okay? Take advantage of those situations. If you got time at the end, plug in all your numbers to actually solve. Okay? We'll go through some of the calculations